Good morning, everybody. We're going to go over yesterday's quiz. You don't have your quiz back, so you can't really tell what you got right or wrong, but you should remember kind of like which questions were hard for you. It should give you an area of focus for your studying, right? So we're still going to do our test tomorrow. Just try your absolute best. Okay, that's like all we can ask, and then we can always reassess things after our week break next week. So just try your best. Do as much studying as you can. Shoot me an email if you need help. Miss Schaub is available during Flex. Mr. Blinkhorn teaches Math 1 as well, so go to him if you need help. Do your best, right? Don't let this kind of like bog you down too much. Okay. Number 1. The value of x in the exponential equation, then they give you that crazy looking equation where a can't equal b, a can't equal 0, and b can't equal 0 is. This information is pretty much irrelevant to us, right? It's just making the question possible. Those are like restrictions on the letters A and B, just to make it so the question actually is functional and makes sense. Next thing, it's asking me to find x, the value of x. If I look at my question, x is in the exponent. When x is in the exponent, we have two strategies we can apply. Strategy number 1 is using like bases. Strategy number 2 is using logs. This is going to most likely be a like base question. The reason it's going to be a like base question is because I noticed that the bases are eerily similar. This one's a divided by b, this one's b divided by a. So they're already pretty close. I always want to try to make the bigger one smaller. So that a to the power 3 and b to the power 3 are smaller. So I want to try to rewrite it in form like that. Okay. First thing that should be obvious is I can take that 3 out. And so I can take that right side. I'm going to leave the left side alone for a minute. I'm going to take the right side. And I'm going to take this exponent 3 out. I do that by going like this. B over A to the power of 3. All right, I took the 3 out. That still has an exponent of x plus 4 above it. So I have an exponent with an exponent, which I'll deal with in a bit. And you can see my bases are now getting closer. The first one is a divided by b. The second one is b divided by a. So we need to flip this somehow. We need to take the bottom and move it to the top, and top move it to the bottom. The way that you move things in your power is by giving a negative exponent to it. Right? So that right side, I could flip that fraction if I make the exponent negative. So it becomes a over b. The fraction flips, but now it's negative 3 instead of positive 3. Like that. Now I have like bases. Wonderful. Okay, when you have like bases, you can ignore the bases and you can focus on making the exponents equal to each other. When you have an exponent with an exponent, that means multiply. So I have 2x minus 3 on the left side equals negative 3 times x plus 4 on the right side. This is a linear equation. So to solve this linear equation, I'm going to have to multiply this negative 3 in. I have 2x minus 3 equals negative 3x minus 12. Then I'm going to move my x's over so they're on the same side by adding 3x to both sides. And then I'm going to move that 3 to the other side by adding it. So my x's should end up on the left. I have 5x. And my constant should end up on the right. I have negative 9. Last step here is divide by 5. And I have x equals negative 9 over 5. B. This is a hard question. It's a tricky like base question. Let's look at number 2. A logarithmic form of the equation 4a cubed equals b, where a is greater than 1 is. All right. So I want to try to turn that thing into a log. To turn it into a log, there's actually lots of different ways that you could do this. Usually, when you're turning something into a log, you need to get the power by itself. This is my power, a to the power of 3. So I need to get that isolated. The 4 is not part of the power. So I need to move that 4 over. So I now have a to the power of 3 equals b divided by 4. We get the power isolated. This allows us to change something into a log. So log, the base of your power is the base of your log. The argument of your log is whatever's on the other side of the equal sign. And then it equals the exponent. The answer should be log a b over 4 equals 3. That's b. The trick to that one is remembering to get the exponent or the power by itself before you change into a log. Gorgeous. Look at this. If log 2 of 3 equals a and log 2 of 10 equals b, then the expression for log 2 of 90 is. So you're trying to figure out what log 2 of 90 equals. If you look at the answers are all in terms of a's and b's. Okay, that's because what they're trying to get you to figure out here is how could you take log 2 of 90 and break it up to be log 3's and log 10's. Because you know what log 3 equals and you know what log 10 equals. So if you could take that and break it up, it should work. The way we're going to break it up is by taking that argument 90 and realizing that 90 can be written as 9 times 10. The reason that would help us is because we know log laws, which say if you have a multiplication in your argument, you could break this up into 2 separate logs added together. And there you go. You got your log 10. Okay, so we're partway there. Log 10 equals b. There's my log 10. What I don't have yet is I don't have a log 3. So I need to take this guy and break it up again. Log 2 of 9 could actually be 3 times 3. That means I could write that as log 2 of 3 plus log 2 of 3 plus log 2 of 10. And now I know what all of these things equal. My log 2 of 3's, both of those are equal to a. My log 2 of 10 is equal to b. That means I have a plus b. A plus b is 2a plus b. The answer is b. Cool. You should find some questions like that in your practice booklet that are kind of similar. It's a little tricky, a little bit of log laws. It's like taking a log and breaking it up into what its original logs must have been. Number 4, simplify the following into one logarithm term. All right, this one, like when I looked at this test and I was putting it together, I think this one's the hardest one. It's the trickiest, I think. So we're going to simplify it into one log term. That means we're going to use log laws to combine things. Before you can combine logs, you have to get rid of coefficients, right? So I suspect that most people's initial attack on this thing would be to move this coefficient to the exponent, which is the right move. So this becomes log a of b plus log a ac to the power 4, like that. Then it gets tricky. There's all kinds of mistakes and baiting tricks that they could probably get you to do here. The first one is probably people trying to start combining these logs. So people looking at this and trying to add them together using your multiplication rule. That's not wrong. It's just going to actually muddy the question more than you needed it to. It's going to make things harder. Instead, what I'm going to do is I'm going to bring this exponent in. To make it look like this, log a of b plus log a to the power of 4 times c to the power of 4 minus 4. And here's where the real trick happens that is hard to identify. You have a log with the same base and same argument. Anytime you have a log with the same base and the same argument, we know that log equals 1. So I can actually simplify that if I was to break these logs apart. So it looks like this. Log a of a to the power of 4 plus log a of c to the power of 4 minus 4. So I took that log and I split it into 2 logs. The reason I did that is because now I have this. The base and the argument are the same. And if the base and the argument are the same, that means that log equals 1. So that means that that term will now turn into this. Log a of b plus 4. The reason it's 4 and not 1 is because that's a to the power of 4, right? So you could imagine that 4 is the coefficient. It means 4 times 1. Or you could imagine it's like asking you what exponent on a becomes a to the power of 4. Right? That's kind of 2 different ways to look at it. But that would equal 4. What I said there was I would take this exponent and I'd make it the coefficient again. And then the log a of a is 1. So 4 times 1 is 4. That is very tricky. It takes a lot of log practice to be able to identify that. Now, before I finish this question off, something else that helped me identify, there must have been a trick here, is if I look back at the original question, I have this minus 4 hanging around. This guy. And I can't combine that minus 4 with a log. There's just no way. Because it's not a log, so it can't use log laws. So that told me that somehow I'm going to have to get rid of that minus 4 because none of my answers have a minus 4. And that told me that somehow I'm going to have to take one of these logs and turn it into a number, which got me looking for things like, do I have a same base and same argument anywhere? And as soon as I recognized, okay, same base, same argument, that's when I recognized I could get rid of these 4s. So now those 4s go away because 4 minus 4 is 0. And I just have to combine those 2 logs. That'll be log a, b, c to the power of 4. The answer is C. Very, 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 very tricky. That is a hard question. Honestly, I think that's the hardest one because of the trick. The math isn't that hard, but the trick is, right? Okay, number 5. If 1/2 log 4x equals y, then x squared is. Okay, so you're trying to figure out what x squared equals, right? Only way you're going to do that is if you figure out what x equals. That means you're going to have to take this thing and solve for x. So x is part of the log. That means I'm going to have to change this into exponential form. You can't change it into exponential form until the log is by itself. So I need to get that 1/2 out of there. The opposite of 1/2 would be timesing by 2. Right? 2 times 1/2 would cancel out. Then I'd be left with log 4 of x equals 2y. And now I can put that into exponential form. It's 4 to the power of 2y equals x. Awesome. That's not the right answer, though, because the question wanted to know what x squared is. You just figured out what x is. So to figure out what x squared is, you're going to have to change x to be 4 to the power of 2y. So I have 4 to the power of 2y squared. When you have an exponent with an exponent, multiply it in. It's 4 to the power of 4y. The answer is A. Tricky. All right, number 6. If log 3x equals 2 and log 2t equals x, then the value of t is. Okay, I'm trying to find t. T is only in this equation. In that equation, there's 2 unknowns. There's a t and an x. So I can't solve for t until I know what x is. This equation will help me find x because it only has one unknown, the letter x. So we got to do 2 parts here. You got to solve for x, put that into the second equation, solve for t. So let's look at that first equation. If I want to solve for x first, I need to change this into exponential form. 3 is the base, 2 is the exponent, equals x. 3 squared is 9. 9 equals x. Now I can go back to this question and I can change x to be 9. Then repeat the same process. Base becomes base of the power to the power of 9 equals t. That means 2 to the power of 9 equals t. I'm going to have to use my calculator for that. 2 to the power of 9 is 512 equals t. The answer is 512. Awesome. Number 7. Use like bases to determine the value of x. Okay, it told you to use like bases. You technically don't have to because it's numerical response. But usually if it says to use a strategy, that's the best strategy to try to use to solve. So let's try it. Like bases, you always want to take the bigger one and turn it into the smaller one. Now, the problem with that is I can't redo 8 as 4 to the power of something, right? 4 squared is 16. It's not 8. So that means I have to actually try to rewrite both of these things as smaller powers. For instance, 4 is the same thing as saying 2 squared. So I could take that first one, I could change it to 2 squared 1 minus x. I could take the second one, and 8 is 2 to the power of 3. 3x. And you can see I've changed the bases now from 4 and 8 to both be base 2. The first one is 2 squared, the second one is 2 cubed. Once you have like bases, the bases go away. When you have exponents with exponents, you multiply. So this is 2 times 1 minus x equals 3 times 3x. Be careful with that. A lot of the times people forget that the 2 has to multiply to both things. So it's 2 minus 2x. Right? It doesn't just multiply by the first thing. That 3 is also going to multiply in to be 9x. A little bit of algebra here. We need to move the x's to the same side. So I have 2 equals 11x. And divide by 11 to get your answer. 0.18 is x. It didn't say what to round to. My apologies. I'll give basically any answer there that rounds properly the answer. Awesome. That's not a bad question for like bases. That's pretty straightforward. It's the trick of realizing how to move both things into base 2, and then remembering that when you have exponents with exponents, you multiply. Those are probably the two biggest tricks. Okay, earthquake questions. Earthquakes can be analyzed with the formula m2 minus m1 equals log a2 over a1, where m is the magnitude of the earthquake and a is the seismic amplitude of the earthquake being measured. The magnitude of an earthquake with triple the seismograph amplitude of a magnitude 5 earthquake is. Oof. Okay, with these questions, I always find them very, very wordy. So I'm going to try to highlight what things actually mean here and just like simplify it a little bit. So earthquakes can be analyzed with the formula. I see the formula. M is the magnitude of the earthquake. I'm just going to write that down. M equals magnitude. And A is the seismograph amplitude. A is the amplitude, right? Let's just simplify it a little bit here. Of the earthquake being measured. Perfect. Now, the question in these word problems is usually at the end. So, the magnitude of an earthquake. I'm looking for a magnitude with triple the amplitude of a magnitude 5 earthquake is. So, things they gave you. You're looking for a magnitude. They gave you a magnitude. The one I'm looking for, I'm going to call M2. The other one I'm going to call M1. You technically could do it in reverse, but this is probably the better way to go because you're talking about the second earthquake, right? Like the magnitude of an earthquake in comparison to the first earthquake, which is magnitude 5. That's good, but then they don't give you any A values, right? They don't say what A actually is. They just say that it's triple. Okay, so what they're saying is that A2 is 3 times triple A1. So I'm going to do this. A2 equals 3 times A1. And now let's look at our formula. So our formula is M2 minus M1, which is 5, equals log A2, which we know is 3 times A1. It's triple the first one. Divided by A1. That's how I deal with the triple. I'm saying that the A2 is 3 times A1, which gives me this situation where these A1s will cancel out, right, in my formula. So I now just have this. M2 minus 5 equals log of 3. If you want to solve for M2, you add 5 to the other side. and you put that in your calculator. So log 3 plus 5, m2 is 5.48. That would be the magnitude of the second earthquake. Now, technically, sometimes people get caught up on like, how do you know it's M2, M1, A2, A1? You could do the same question backwards. So if you called the first one A2 or the first one M1 and the second magnitude 2, it still would work out. So it doesn't really matter which one you call the first and then which one you call the second, as long as you keep it consistent. Awesome. Those are super like wordy and confusing. Like I do get that. Number 9. If the point k, 3 exists on the inverse of a function y equals 2 to the power x and the value of k is. Okay, so they give you a lot here. The point k, 3 means they gave you an x value, right? X, and they gave you a y value, y. It exists on the inverse of this function. So it's not on that function, it's on the inverse of it. Inverse means switch x and y. So if it's on the inverse of that function, it's actually on this function, x equals 2 to the power of y. I switched the x and the y. Find the value of k. All right, well, if I'm looking for k is x. They told me that y equals 3. So I'm looking for x. They told me y. I go to this equation, and I change y to be 3. The answer is 8. The trick there is knowing what an inverse is, and then realizing that a point is just an x and a y value, right? Anytime you give you a point, they're giving you x's and y's. Fantastic. Okay, graphing. So we're going to graph this thing and then complete the chart. We're going to graph it first with at least 5 labeled points. Okay, so your graph should look like this. Should look somewhat like this. The reason I know it looks like that is because it's a log graph, right? It's a log 2 of x. So it should look like this, somewhat. But we need it to be detailed. So detailed means you need at least 5 points. So you're actually making good connections here. So to draw this nicely, you need to find exact points on this graph. There's different ways you could do that. You could graph it in your calculator, and if you go second graph, it'll take you to a table of values, and it'll give you a bunch of points that you could then draw. Or, if you want to do it by hand, you take y equals log 2 of x, and you just start choosing values for x. So, what happens when x equals 1? When x equals 1, you get log 2 of x like that, but it's 1 instead of x, my bad. You put that in your calculator. And you would get y equals 0. So there's my first point, 1, 0. And then you could do another one. So you could do, okay, what happens when x equals 2? And you go to your original equation, you change x to be 2, and then you calculate it, and you should get the y equals 1. So there's your second point, x equals 2, y equals 1. And then do a few more. And you can do like any x values you want, right? So you could do like what happens when x equals 4. Well, go to your equation and change x to be 4. As long as you choose points that that are on the graph, so any of these x values, and you graph them, I'll be happy. So 4 and 2 would be here. Like, you don't have to do the same points as me. You just have to have 5 accurate points. So that one was 4, 2. Yeah, and do a couple more. So what happens when x equals 6? Y equals log 2 of 6. You put that in your calculator. We're going to have to round this one. That's 2.58. So 6 and 2.58. Right about there. And we'll do one more. Let's do what happens when y equals 10. Or sorry, x equals 10. And this is how I'm getting all of my points. Actually, I should have done 8. Yeah, it's okay. Actually, let's do 8, and let's talk about why I should have done 8. The reason I should have done 8 is because 8 is going to be a nice number. The reason 8 is going to be a nice number is because remember what logs are asking you. Right? It's asking me, what exponent on 2 becomes 8? Right? And 8 is actually a power of 2. So the answer will be 3. And 2 to the power of 3 is 8. So that's probably a better one to graph. So 8 and 3 would be right there. And now I can just kind of connect the dots. To make my graph. To have a perfect graph, you need to have all 5 points on there. You need to label your graph. Okay, so this thing was log or y equals log 2 of x. You need to have arrows on the ends of your graph. So notice that I put arrows there. And you need to have any asymptotes drawn. So asymptotes are lines you can't cross. Remember, on a log graph, I can't cross the y-axis. So I have a dotted line on the y-axis that represents the asymptote that I cannot cross. That is a good-looking graph. Beautiful. With that graph, let's go and answer our domain, range, all that jazz. So the domain of that thing would be x values such that x is greater than 0, comma, xer. What that means is that x could be any value bigger than 0. If you look at our graph, that is exactly what's happening, right? It's to the right. I can't go further left than 0. So it's anything bigger than 0. It's to the right of 0. The range is how far up and down a graph can go. This graph technically goes forever up and forever down. So the range is just YER. The x-intercept. There is one x-intercept. All logs have the same x-intercept. It's at 1, 0. And if you look, we actually found that point. It's the blue point, 1, 0. That's my x-intercept. My y-intercept. There is no y-intercept, so you can put none available, or you can put none, or no x and y-intercept, whatever, as long as you say there's none. And the asymptote. The asymptote you could write as the y-axis. That's probably not the best way to do it, but you could, and I'd probably give you the mark. The best way to describe that is x equals 0. So vertical asymptotes, up and down asymptotes, are always x equals something. And it's wherever it crosses the x-axis. So this is x equals 0 because it crosses the x-axis at 0. Oh. Okay, fantastic. So there's your chart, and there's your nice little graph. Last question. I was sad I wasn't here for these questions. These are my favorite questions. These are exponential functions. Real life examples, right? So when you buy something or anything that grows or shrinks at a percentage rate follows an exponential function. So Mr. Kennedy bought a motorhome for $60,000. He determines that the motorhome will lose 10% of its value annually. So what that means is that my car is going to depreciate. It's going to go down in value, all right? Create an exponential function to represent the value of Mr. Kennedy's motorhome. All right, it tells you to create an exponential function. In our video the other day, we made a formula for exponential functions for these like money compounding interest type problems, okay? So it looks like this. You got A equals P1 plus R over N and then NT. And if you look back in your notes, like we had values for all this. I'm just going to put what I call these values because it's not always like the proper terms. This is like the value of something. I like to call it the end value. So in this question, it would be the ending value of my motorhome. P technically stands for principal, right? I like to just call it the start value though. Okay, that's what I started at. Purple is where I'm going to end. Then I have 1 plus R over N. R is the rate. N is not going to apply to us in this question. N is how many times you compound something. So that's like how often you gain or lose that percentage. The reason N is not going to matter to us is because they told us that we lose 10% annually. That means 1 time per year. In other questions, like our savings questions and stuff, you would maybe like compound monthly, which would be 12 times a year, and then N would be a value. So for us, N is just going to equal 1 in this question because it's 1 time per year. It's compounding annually. These N's are the same. Okay, so if it was compounding monthly, both N's would be 12. If it was compounding semi-annually, that's twice a year. So it would be 2 in N. And then we have our friend T over here. T is time. In this case, it would be years, right? That's usually your variable that you don't know and you're going to manipulate and change. So if I wanted to do this question, Mr. Kennedy bought a home at $60,000. That's my starting value. So I have A equals $60,000. He determines that the motorhome will lose 10% of its end value annually. So that's my rate, right? 10%. But I'm losing 10%. So my rate is minus 0.1. Right? I'm losing, so it's negative 10% as a decimal is 0.1. And then to the power of n, which we don't need, right, because it's annually, so it's just 1 to the power of t. You should simplify inside those brackets. I mean, I would probably give that whole marks, but I shouldn't. 1 plus minus 0.1 is 0.9. That is my exponential function. I don't know the end value, I don't know the time, but I did know the starting value and I did know the rate. I can then use that function to answer questions about this motorhome. So question B says, using the equation from part A, determine the value of Mr. K's motorhome in 5 years. There's my time. They asked to find the value of the motorhome. Determine the value of the motorhome. That would be my end value. So I'm looking for A. I know T. I go back to my equation. That means I leave A as A, and I change T to be 5. Throw that in your calculator. And you should get, that's too much money. You should get 35,429.4. That would be the value of my motorhome after 5 years. Part C, using the equation from part A, algebraically determine how long it will take for Mr. K's motorhome to be half its original value. Okay, it asked me for how long. Determine how long. That means I'm looking for time. So it means it should have given me an A value, right? Because that's my other variable. So how long will it take for motorhome to be half its original value? Well, it was worth 60,000. Half of 60,000 is 30,000. So I go to my equation. I change A to be 30,000. And I leave T as T. My job is to solve for T. It has to be done algebraically. T is in the exponent. That means I'm going to have to change this to logs. I can't change it to log until I have the power by itself. So I divide 60,000 to the other side. And I now have 0.5 equals 0.9 to the power of T. To solve for an exponent, we change this into a log. So I have log, base of the power is base of the log, 0.9. Other side becomes the argument, 0.5. And the exponent is now by itself. You put that in your calculator, and you get 6.58 years is how long it would take. Fantastic. I hope that helps seeing all those questions. It's a wide range that basically covers every topic that we learned. Keep practicing. You've got this test tomorrow. I have faith in you. Even if you don't have faith in yourself, I have faith in you. So you've got this. Shoot me emails if you need help. Some people have been emailing me. I try to help. It's hard to help sometimes via email, but I will always try my best. Take care. I'll see you guys soon.